Hi, everyone. Yeah, I'm Pete, or Mr. Shanty on the online. This is Intermediate Representations for Reactive Structures, which is a title that, after some thought, I thought that maybe that's not totally clear. I had another go at the title, which is it's cool to share tools, which is also not super clear, but I don't know, maybe somewhere in the middle it's starting to make a little bit of sense. Anyway, yeah, so I'm going to talk about two crates that I've been exploring, two areas that I've been exploring. And particularly what I'm interested in is how can different ecosystems empower each other, by sharing tools. And it's kind of space that I've been looking into. Okay, so the reason why I'm using this term intermediate representation is I'm using it a little bit loosely. But it's just for that idea that, for example, if we're talking about a file format like GLTF, right? It's like, it doesn't really matter who's authoring it. The output's going to be consistent, right? But when we're talking about an IR, you can actually have completely separate ecosystems. So this could be, for example, web development, a web development workflow. That could be a game development workflow. That could be like graphics workflow. That could be robotics. They could be completely separate, but they can still share the same tools. So that's kind of the reason why I've landed on this, the usage of the term IR. There's a couple of characteristics to what they call a good IR. First of all, it's got to be expressive. So, for example, let's say if this was a web dev workflow, it's important that the IR doesn't limit what that workflow is trying to do. It has to have full capabilities, and so yeah, so it's important for them to be expressive, and it's also important for them to be independent. So, for example, if this one's outputting HTML, that one's outputting like I don't know, BSN or something like that. The one's not forcing the other to be in its format or in its like ecosystem, right? They've got to be able to remain sort of pure and in their own space. Of course, the most famous and probably one of the most celebrated forms of an IR is LLVM. That's very low level. That's kind of like where we can all agree what a function is, and we can all agree what variables are. And so whether we're writing a Rust program or doing a SQL query, suddenly the implementers of those libraries or those languages don't have to worry about reinventing the wheel. We can all kind of share tools and get massive gains from that. I'm gonna be talking on a sort of higher level on the application layer rather than the language layer. Okay. So this is in robotics or electronics. Blinky is like the hello world. It's sort of been around, like you could say, since the 80s, since these sort of hobbyist electronics movements. It's very popular, and I guess something that I've been very interested in is what's the 2025 version. And like Blinky's great for learning hobbyist electronics, but now with all these new capabilities that we have, is there a new kind of hello world that we could be looking into? And for me, this is probably the best representation I can think of.
What is my purpose?
You pass butter.
Oh my god.
Yeah, welcome to the club, pal.
Right. So there's the butter passing robot. So like it's a little bit funny, but like what Rick's doing there is like he's just at breakfast. He's got some idea. Oh, I need the butters all the way over there. I'm just going to whip up a little robot. It's going to go and get me the butter, right? It's kind of like this, like, sci-fi fun idea. But you think about it, like in 2025, it's like, well, I don't know, maybe that's possible. Like if we got a few things right, maybe that kind of thing, that kind of expressiveness, and the capabilities, what we could have, maybe that's within reach. But there's one of the other things that strikes me about that kind of example is it's very multidisciplinary, right? You've got like it's got like hard robotics. It's got like things like computer vision, all that sort of thing. It's got the hobbyist element where it's actually it's not like in a factory. It's actually just doing something fun around the house. It's a character, so you actually have like character design, things like animation. So it's like if we were serious about how would we create this kind of hello world, this kind of like make this sort of thing easy for like, children to create, we're really going to need all those capabilities, and we're going to need like pretty powerful tooling to be able to get that done. And in particular, something in particular that I think would absolutely be necessary will be simulation, right? So you'd want to be able to make sure that you can do that, test it all out inside, for example, a game engine. Okay, and so the reason why, like, we've all got our reasons why we came to Bevy, why we thought it was such a cool piece of technology. The reason why I got excited about Bevy is, and this is the best way I've been sort of able to sort of describe it, where you've got this idea of, for example, ESP-IDF, that's like your super low level. That's probably what the chip in your fridge, that's probably what was used to develop that, right? So you've got like, that's something that it's really good for developing robotics for professionals, right? Something like Arduino is, okay, professionals use it, and also hobbyists use it, sure, but it's really pretty much for robotics, right? And that kind of limits the breadth of how do you say it? Like, of ideas of the ecosystem, if it's kind of just in that one sort of space. Or for example, Scratch, or I should say Blockly, which Scratch is kind of built on, right? Okay, well, people do robotics on it, people do graphics on it, but we haven't seen that kind of depth, that kind of professional usage of that kind of software. And so for me, what strikes me about Bevy is that it runs on a tiny ESP32. It runs on these tiny microcontrollers, and we're also got like this massive ecosystem of a game engine. And so yeah, so that's why I'm excited about Bevy, and I'm kind of exploring Bevy as a space, but beyond graphics. And this kind of led me to Beat Flow. So I describe this as a control flow library. Really, it's being used for things like behavior trees, like game AI. But the reason why I call it a control flow library is at its core, what it really does is, you got a node, you run it, and then it's going to run a child node, or select which child node to run. That one's going to run. The sort of the core of it is what you could call like a request response observers. You could think of it, for example, a behavior tree is like a parent asking a child for a run result, right? Did you succeed or did you fail? And maybe that'll return immediately, maybe it'll take some time. But for me, the important part of this library is that it's using Bevy scene, right? It's just it's just entities, which if you thought through how, for example, visual programming language would work in Bevy, like you kind of imagine that all those nodes would be entities, right? And that's the kind of cool part of what you can do with Bevy. Yeah, so it's multi-paradigm. Like all we're talking about is control flow, right? So you can create kind of anything you want on top of that. It doesn't have a blackboard. It's just using the Bevy world. So being able to create all kinds of paradigms. The only one that I've gotten really stuck on is like this kind of GOP or HTN. That's kind of this idea where you have like a hypothetical world where you say like, okay, well, if I were to do this, then what would the next world state be, and what would the score be, or like how beneficial would it be for me to do that? And so I haven't yet found a clean way of sort of replicating the world in that way. But yeah, who knows? It's just the way that it is at the moment. Where are we at? Okay. All right. Yeah, some examples. So let's see if whoops. Sorry. Okay. What have I done? Let's try that again. So this one is what you call like a sentence similarity. It's kind of like very basic, very, very basic LLM. It can run on the CPU. It runs in the browser, no problem. And what it's able to do is, like, let's say you give it a bunch of targets. So here it's got like a piece of cheese, a coin, a sword, and a potion. And you can give it things like, for example, I've been injured, and it'll be like, oh, okay, well, I'll go to the potion, right? You sort of give it like it's able to score kind of like utility AI, but using sentences to work out, I want to be rich. Oh, I'll go get you a coin, stuff like that. So these are all, just as a reminder, these are all my attempts to get towards that butter passing robot. Here we also have reinforcement learning. This is the frozen lake, is a little bit like the hello world of reinforcement learning. It's a very famous example for RL. And so you wouldn't actually do training like this. You just do that for debugging. If you're actually training, you probably wouldn't want to render every frame. It just takes a lot longer that way, but it does look a bit fun. This one's just an exploration of like again, because if we're talking about these sort of robotic characters, you also need this expressiveness. And for me, it's really important that these things are really cheap, that like it is for hobbyists. So, exploring, for example, if you were to have a phone on one of those, like, robotic arms, how would that work? Some of those animations. And here it is just running on a little ESP32. So that's just doing the Bevy on a little microcontroller. All right, just give me a moment. I'll see if I can get those slides full screen again. All right. Okay. Right. So should be able to. All right, that's that. Okay, on to templating. So this is the second one that I've sort of been exploring. What's a template? A template is where you've got a little bit of data, and you've also got some. Let's say you've got like some structure. What I'd call a reactive structure. You're co-locating your code and your structure. So this is actually this is the same as this is a Leptos what do you call it, parser, the same parser that Leptos uses called RSTML, and so just exploring like if you think about it, like maybe I've got these slides out of order, but exploring what is a template made of, and how can we find some tools that would be able to share. So first of all, just to explain exactly what's going on here, is if you sort of squint at what these templates are, is it's like half structure and half code, right? Whether you're talking about HTML or BSN or anything like that, you're going to have some of it's going to be sort of fixed structure, which really could be like in an asset file, but we don't want to do that because then you've got two different files. That's quite difficult to work with. You want to co-locate it, but some of it's static, right? And whether you're talking about web pages or scenes or behavior, like in Beat Flow, you still sort of got this. You still got this this pattern. It's all kind of the same sort of stuff, right? And so this is an area that I'm very just most recently just been exploring. Are there opportunities for shared tooling? And so far I've been looking into hot reloading. So this is the kind of hot reloading that you'll see in Leptos or in what's the other one? Yeah, so I can't remember the other one. There's Dioxys. Dioxys also has this kind of hot reloading, but like all the frameworks like everyone's got to create their own hot reloader, right? And of course, Bevy's going to have something similar to this as well. And so like I'm wondering, like, is there an opportunity where we could actually, I don't know, Leptos and Bevy could work together and sort of share tools. So what I've been able to do here is kind of have a process that's looking at the file and saying, okay, well, I know the file changed. Well, when the file changed, was it the going back to that slide before, like, was it the code part or was it the structure part? Because if it was just these static parts, then we don't actually need to recompile. We should be able to just extract that, right? So that's what that's doing. So then you're talking about, what, 2.6 milliseconds to re-render that. And again, like these examples on their own, maybe they're not terribly interesting, but it's the same technology. So for example, this is it, same thing being used for Bevy, and yeah. So I'm not suggesting that we use HTML markup for Bevy scenes. What I'm suggesting is that we use the same underlying technology for Bevy scenes and for example, Leptos web pages, and maybe use the same markup. Like for example, sorry, here we go. Going back to this slide, like I don't know, like maybe if you're making a website with just a little bit of scene, maybe you do want to use a HTML markup, or maybe if you're using a game with just a little bit of website, maybe you want to use a BSN markup. I don't know, but I feel like there's opportunities for collaboration, and that's what I'm exploring with Beta RSX. All right, I think that's everything. Oh yeah. Okay, sharing is caring. So, of course, the JavaScript ecosystem is massive, right? They've got so many people. We don't have so many people, but we've got very creative people in the Rust ecosystem. Our web dev and our game dev communities, they're small, but they're creative, and our language is really powerful. Rust is a really powerful language. I feel like there's a lot of opportunity for us to collaborate and have these ideas of intermediate representations, where even if we're completely separate ecosystems, whether it's graphics and robotics or web and game, like I feel like there might be some opportunity for collaboration.
Hey Pete, thanks so much. That was interesting. So my first personal question is, which part of Bevy crates did you use in your robot?
Which Bevy crates?
Yeah, is there any parts of Bevy running on this robot?
Yeah, that one is purely Bevy ECS. I think that original
nice.
one actually just used like Bevy _ ECS as a dependency. Although yeah, in the future I'd be more interested in for example, looking into something like if Replicon could run on a robot, that would be awesome. Something like that would be very cool. So could
nice.
be reflect as well would be useful.
So you would make the different players in a Replicon session be different actual robots.
Right.
Interesting. Okay. There's only one question left, so let me quickly go to that one. Do you know if reactivity in Bevy will use a similar approach, like what you did with RSX? Are you following that?
It's a good question. I don't know. Like the way that the Bevy community works, I feel like there's going to be 20 different ways that reactivity is going to work in Bevy. The way that works, the way that particular example works. Where is it? That one? Next one. The way that works, that's just using observers. So that on click is literally just an observer with an inferred trigger type. So observers get us pretty far with reactivity. I don't know. I don't know. It'd be really interesting to see how it goes with BSN and once we start getting really serious about creating UIs. Yeah.
So that's what's used inside of this Bevy signal type that I see there.
Yeah. It's like observers dressed up as signals, or like with a signal like API. But yeah, it's just an observer. Yeah.
Interesting. Super cool. I wish I have ever time to build a robot as well and run some Bevy code on it. That's amazing.
Yeah. That's fun.
Okay, Pete, thank you so much. I'm going to put up Chatur again, and we can go through the rest of the questions together.